MongoDB, so workshop on MongoDB with Spring Boot integration. This is the topic, guys. Workshop on MongoDB with Spring Boot integration. My name is by Mr. Vijay Kumar, instructor. Right. So let me start here. A small introduction from my side. My name is Vijay Kumar. I'm currently working as an architect, overall having 20 plus years of experience. So I'm currently working with Ashok IT in the morning and evening few hours. So the topics which I'm currently working with Ashok IT are Spring Boot, Microservices, Angular, React, and Full Stack and Microservices design patterns. So these are the currently courses I'm teaching with Ashok IT. This is a small introduction from my side here, right here. Now, agenda for today's workshop. Typically, what is MongoDB? This is the first topic which I'm going to discuss here. And why MongoDB? Second topic is relational database versus MongoDB. Third one, limitations of MongoDB. Limitations of MongoDB. Fourth one is integrating or will create a Spring Boot application. Will create a Spring Boot application which connects to MongoDB on a e-commerce platform use case or with e-commerce platform use case. With e-commerce platform use case here. And finally, Q&A. So my intention was Q&A will be, I'll take it up, okay? For every 10 minutes or 15 minutes, something like that, I'm going to take it Q&A, okay? If you have any questions, please put the questions in the chat window. Please put the questions in the chat window. For every 15 minutes or 20 minutes, whatever the timeline is concerned, I'll go to the questions, I'll answer to the questions. The questions I'll take it up only if the question is relative to what is my focus area, that is MongoDB with Spring Boot or anything with Spring Boot. Okay. So outside questions, I'm not going to entertain, guys. Okay. Kindly cooperate on that right here. So this is the topic which I'm going to further, and this is my agenda for upcoming few hours. Okay. What is a MongoDB and why made MongoDB? Relational database versus Mongo database and limitations of Mongo database. And we are going to create a Spring Boot application with MongoDB as a platform. And what I'm going to take here, I'm going to take care of use cases, typically e-commerce platform use case here. So that is a typical point over here, guys, here. Right here. Now, without wasting the time, I'll go to the topic here. Right. 1 second. Yeah. I think, oh, yeah.
Yeah.
Right. So, guys, I think just now it's recording is started, guys. I think I missed it recording part. Okay. Right. Now we are going to focus further here. MongoDB. What is the real meaning of a MongoDB? Okay. So MongoDB is a NoSQL database. NoSQL database, meaning it's not based on traditional relational database structure. It is not a traditional relational database structure like Oracle, SQL Server, MySQL, etc. Instead of tables, relations, joins, we can store the data in raw format without any relations, So this is a simple introduction to MongoDB. The data will be saved in document format. The data will be saved in the document format, which we call that as a BSON, binary JSON. BSON is nothing but a binary JSON, which is similar to JSON only. JSON means what? JavaScript object. Similar to JSON only. This allows to store more complex data types and structures, making it more flexible for real-time scenarios. So I'm going to explain. This is a very, very important, guys. What is a MongoDB? Definitely people will ask you a question, guys. MongoDB is a NoSQL database, guys. So MongoDB is a NoSQL database. It's a not like a traditional way of saving the data. So what is a traditional way of saving the data? And what is a document? And what is a BSON? So I'm going to explain with an example, guys, here. It's not the theory. I'm going to explain an example. Okay, guys? So mostly everyone will like a e-commerce platform, guys, here. Mostly everyone will like e-commerce platform, right, guys, here? So I will take the e-commerce platform example and I'll explain with that. So use cases, I mean, whatever the use case which I'm trying is, assuming that Mr. Vijay logged into Amazon. Mr. Vijay logged into Amazon and ordered iPhone with credit card payment. Mr. Vijay logged into Amazon and ordered iPhone. With a credit card payment. This is the use case, guys, here. Okay, maybe what I'll do, iPhone, comma, iPhone cover, comma, screen guard or screen protector, something like I want to. Okay, so this is a use case, guys. For this particular use case, how that we are going to save the data? How we are going to save this data? This particular use case, how I am going to save the data? Correct, right? So what is the use case, guys? Mr. Vijay logged into Amazon and ordered iPhone cover and screen protector, and he has used a credit card payment and he placed the order. But this particular transaction, we want to save the data into the database. How the data structure, how the schema structure, how it's going to be the schema structure, guys, here? Typically, we are going to have a schema structure of, okay, couple of tables. We are going to have couple of tables. What is the first table, guys, here? Let me take a customer table. First of all, customer should be available, right? Customer table, which is having customer ID, customer name, customer address, customer mobile, customer email. Lot of other things, but these are important things here. And here, customer ID is typically a primary key. Primary key means what? It's a unique, right? Primary key is typically a unique. That's a customer table. Correct. All the customers will be saved into the customer table. So in this case, what I'm going to do here at this particular time, what exactly my data here, assuming that I have a enter customer ID 1, Vijay Kumar, Hyderabad 1211, and Viju MCA at gmail.com. So this is my data, guys, here related to my customer table. Just like I'm giving this kind of data, guys, here. This is I'm giving some data like this, guys. Okay, right. Let me. Right. After that, what is my next table, guys, here? I'm going to place product table, guys, here. Correct, right? I'm going to take a products table. So that's the next table here, where we are going to save product ID, product SKU, product name, quantity available, price. This is my typical product table. Here, this is a primary key will be product ID will be the primary key here. Product ID will be what? My primary key here. Next, I'm going to take one more table. Maybe I missed this. So where I'm going to enter product ID. So my iPhone, right? 101 is the product ID. Product SKU, iPhone 111. Product name, iPhone. 10 quantity available. Price is 1 lakh, assuming that. Next, 102, iPhone 112, iPhone cover. Quantity is this much. Something like that. And the product price is equal to 2000. and I'm taking one more product, iPhone 113 protector, and 500 rupees, something like that. So this is my typical data, guys. Here, some products data here, 101, 102, 103, and this is my products data. So customer data as well as products data. This is my customer and this is my product. And right. Now, what is my next table, guys? Here, I am going to have a order table, guys. Here, correct, right, guys? Here, I am going to have order table. So this is the next table called as a order table. Order table. So which is equal to order table, where I am going to have order ID, order date, order ID, order date, order status, order status, ship, maybe order status, shipment status. Exactly. Something like this is a order details. And also here, one more table. I mean, this entry is having typically what entry it is going to have, guys? Order ID 1, order 1, order date 2/2/2025, something like that. Created, empty status as of now. Something like as of now, no shipment status. Something like that. This is my order data here, right? So customer data, products data, as well as order data. Next one is what? For a particular order, we need products, right, guys? Here on this order, how many products are there? That will be saved in one more table called as order underscore products. One more table called as order underscore product. Something called as order underscore products. For that order, what is the product? Here, order ID will be the primary key, a foreign key, as well as product ID will be a relation here. Order ID as well as product ID. So order ID, product ID, that will come over here. Here, order ID, product ID are the primary keys of order table as well as product table. They will become foreign key here. They will become a foreign key here. So something like that. I'm going to have order ID, product ID, ordered quantity, discount, something like that. So here, what exactly my data is going to have? Order ID, order 1, my data here. Order 1, product ID 101, quantity 1, there is no discount. Order 1, 102, quantity 1, no discount. Order 1, 103, 1, no discount. Something like I'm going to say 3 records in the order underscore products table. Correct? And what is the one more table? Order underscore customer. This order is placed by which customer? That's one more. Correct? So we are going to take order underscore customer. Something like I'm going to take one more table, which is order underscore customer. So which is going to have order table and customer table. Something like that we are going to set up. So here my primary foreign keys are typically order ID as well as customer ID. Something like that. Okay, which I'm going to have a columns, order ID, customer ID. And if at all the type of payment, if this customer is having some kind of, we have a wallet, right? Wallet amount, if any wallet is used, something like that. It's optional, but order ID underscore customer ID. So what is the data here I'm going to have here? What exactly the data? Order 1, customer 1, wallet is 0. Something like this is my order underscore customer. That's the final here. After that, I'm going to take last table. I mean, there are a lot of tables here. There is a one more table which I need to take, guys, here. That is order underscore payment. Order underscore payment. But prior to that, what we need, sir? Payment types. I need a payment types. Correct, right? I'm looking for payment master. Payment master table, which is equal to, I'm going to have one is a Google Pay, 2 Phone Pay, 3 credit card, 4 net banking, something like that. If any other payment options are there, all the payments are in this particular payment amount, payment master table. Now I'm going to have a order underscore one more table I need here, order underscore payment. So here I'm going to have order underscore payment. This is order underscore payment here, which is order ID, payment ID. These are the columns over here. Order underscore ID, payment underscore ID, and payment status. Something like that. This is my order underscore payment here. And what exactly my data over here? Typically my data here, order 1, payment is what? 1,02,500. Is it correct? 1,02,500. That's the order total. And payment ID is with Google Pay, and order status is, payment status is completed. Payment status is completed. So this is a sample minimum use case I have taken, and this is my relational database model, where we were able to save the data into multiple tables. We were able to save the data into multiple tables and with primary key and foreign key. This is the relation which I am going to keep here. This is a structure which I am going to keep in the Oracle or SQL Server or MySQL, whatever the database I am going to save here. But, sir, if 1 lakh people at the same time, if 1 lakh people at the same time, they are placing an order, how many rows a database should have? Almost database is going to have at least 10 lakhs to 20 lakhs rows. So DDL, DML, DQL, I mean create tables, update tables, alter tables, insert rows, update rows, delete rows, select rows. All these queries, almost all it will generate 10 lakh to 20 lakh queries it will going to generate. So there is an impact on the database value, more number of queries are triggering to database here. Apart from that, if I save this entire data in a JSON format, right? If I save this entire data in a BSON, binary JSON, something like that, how my structure, what exactly my structure of binary JSON here? What exactly my structure of binary JSON over here? Where simply I will take the data over here. Simply I'm going to take the data over. Okay. And inside the data, I'm going to take it order details, something like that. Order ID, order 1, comma, product, the inner JSON, product ID 1, product name, iPhone, quantity 1. After that, an array of products, comma, one more product, product ID 2, cover, quantity 1, comma, where product ID 3, protector, quantity 1. This is my product, customer, inside that a nested JSON, cust ID 1, name Vijay Kumar, something like that, a nested JSON. After that, a payment which is equal to pay ID Google Pay and UPI ID Vijay at HDFC. This is my payment details. Shipment, zip code 5,37,000 Hyderabad, something like that. So if I save this as a JSON structure, if I save this as a JSON structure, like order details, product details, customer details, payment details, shipment details. Like by default, all these details will be saved in a one particular document. If I want to save this entire data into one particular document so that I can minimize the database lookup or database operation. So this is the sample use case for a simple MongoDB where a complex data structure, where we can minimize to a simple data element, a simple document. So this is the high level overview of what is MongoDB. Now I'll come back to my definition, guys. Here, MongoDB is not a traditional database structure. Instead of tables, relations, joins, we can store the data in the raw format. Without any relation, no relation, nothing. And we are going to save in the form of a document. This is the high level overview of MongoDB, how data will be saved in case of MongoDB. But immediately we'll get it out. Sir, no one will save the data like this. Generally, no one is going to save the data like this. Everyone will save into relational database. Everyone is going to save the data into relational because we need some reports. How many orders are placed? How much is the discount is applied? How many orders are? So we are going to save the data, but we are going to look for the data. We are looking for some kind of reports. So for that, I need to query the data from the database, where MongoDB is not a best option for data retrieval part, because we are going to save the data in the complete a document format where we cannot apply any queries. No SQL queries we can apply, but simply getting the document, updating the document, all those. Then why MongoDB is very, very popular? When we are going to save the data in the database, that to relational database, without any relation, without any structure, then why MongoDB is famous? So by default, guys, MongoDB is introduced by default. Here, what I'm trying to say here is, then what is the use of MongoDB is, initially MongoDB is created for images, a unstructured data. So what is the point here? MongoDB is invented for storing unstructured data. What do you mean by unstructured data? A data which is having no structure at all. No structure. Something like a file, PDF, photo, image, video, etc. Do we have any structure like this, guys? Do we have any structure for this? For a file, I can store characters, I can store numbers, I can store any of the things. In PDF, I can store any type of data. Image, I can store any type of picture. Video, I can store any kind of video content. So by default, what I'm trying to say here, these all things are unstructured data. So if I want to save any kind of unstructured data, where we can use MongoDB. MongoDB is specially created for this purpose, guys, here. But slowly, the MongoDB is extended for or leveraged, or MongoDB is also created for some other purposes where a complex join, okay, it's also used for saving complex joins, complex data lookups, etc. Complex data joins and complex data lookups and all those things typically, etc. guys. Okay. So what do you mean by complex join? What do you mean by complex data lookups? I'm going to explain that, guys, here. Okay. Now I'm going to take a scenario, guys, here. I'm going to take one more scenario to explain clearly. Okay. So what is a complex join? What exactly a complex database lookup? All those things I'm going to take here. Okay. So what is my use case is Mr. Srikanth joined or logged into Swiggy Instamart. Everyone knows, right? Swiggy Instamart. And he put 20 products in the cart. 20 products in the cart. Mr. Srikanth logged into Swiggy Instamart and he put 20 products in the cart. Understand, guys? Now, he has not done any payment. Srikanth has not done any payment. After 15 minutes, again Srikanth logged in. Again Srikanth logged in. After 15 minutes, again Srikanth logged in. He can see he should able to see. He should able to see the 20 products, whatever he added. 20 products, whatever he added in the cart. Correct, right? Assuming that he removed all 20 products, all 20 products he removed and added new set of 20 products and added new set of 20 products. This is the scenario, guys, here. Let me repeat my scenario, guys. As of now, let me repeat my scenario here. Mr. Srikanth logged into Swiggy Instamart. He was able to add 20 products in the cart, but he has not done any payment yet. After payment, after 15 minutes, okay, Srikanth logged in again and he was able to see the 20 products and he removed all the 20 products and he put a new set of 20 products. Then how many database calls are going to make, guys, here in this particular case? How many database calls going to happen here? How many database calls are going to happen here? One row into order table. Correct, right? One row into order table. One row into order underscore customer. Right? 20 rows into order underscore products. 20 products he added, right? 20 rows in 20 rows into order underscore products. After that, one row in payment is not done, right? Order underscore customer, order table, product table. That's it as of now. And one row in the customer is already laid. So order table one row, order underscore customer one row, and 20 products in one row. So almost 22 queries, 22 inserts, 22 insert. Now, this is the case for that. What I am doing here, after 15 minutes, Srikanth logged in again. He should able to see 20 products, and he removed 20 products and added new set of 20 products. Then what is the case here? 22 selects, because we need to see the data, right? 22 select statements, not 22, sorry. 3 select statement, order select, order underscore customer select, order underscore product select. 3 selects. After that, 3, 1 delete. 1 delete means, 20 products delete, right? You need to delete the 20 products, right? 20 delete statement, because he is removing all the 20 products. After that, 20 inserts, which is equal to 43 rows or 43 database statements. Overall, 43 plus 25, 65. 70 database statements are going to trigger in this particular format just for a simple use case. Just for simple use case, 20 database statements are going to be passed. Correct, right? If 1,000 people in a fraction of 5 minutes, 1,000 people in a fraction of 5 minutes, and 100 products each and every customer is having, so almost 1 lakh of database calls are produced. This is a very, very tricky situation in handling real-time scenarios of database volume. Database is a costly call. Now, more number of database calls, more time it is going to consume, and it is going to impact the performance of the application. It is going to impact the performance of the application. So here, in this case, we can use order.json, and I'll keep all the, what I'm going to keep here, guys, I'll create one JSON object, order.json object, something like that. Okay, order details, one JSON entry. After that, product details, one array of JSONs. How many products are there? That many JSONs here. So after that, that's it, right? Order details, product details, only one row. This is like we are going to create only one row, but when he removed 20 and he is keeping one more sentence, new order JSON, only 2 rows are impacted here, right? So, which is nothing but new product details. He'll remove the old product and is going to keep new products. So, instead of 60 to 70, less than 5 to 6 queries, it is going to happen. So that is how this particular use case is very, 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 very useful. Understand, right, guys? Here, this query is going to be very, very useful. So it is going to save a lot of database volume. This is the typical use case. So what I'm trying to say here, guys, here, MongoDB is especially useful for saving unstructured data like file system, PDF, images, videos, as well as complex joins, all those also. Apart from that, if at all, if I have a lot of data, lot of inserts, updates, deletes are going to happening, lot of inserts, lot of updates, lot of delete are typically going to happen in that particular case here. So by default, it is going to save this particular call volume, data volume, and database lookups. All these things will be decreased over here. So this is a very possible use case, guys. In interviews, people will ask you, what is MongoDB? What you are going to do with MongoDB? How you are going to save the data with MongoDB? How you will work with MongoDB? Do you have any real-time exposure on the MongoDB? So I can explain these all those things here typically. Okay, right here. So a couple of questions I'm going to take, guys, here. Yeah, I think right. I don't see any questions as of now. If anyone has any questions, guys, please put the questions in the chat window, guys, here. Okay, please put the questions in the chat window. I'm going to explain this as of now. Yeah. Now what I'm going to do is I'm going to create a Spring Boot project. I'm going to create a Spring Boot project over here. Right. Now I'm going to create a Spring Boot project over here, and I will use the e-commerce use case. I'm going to use a e-commerce use case here. So let me create a folder here. NoSQL workshop. I'll create a folder over here. By default, I'm going to take a NoSQL workshop over here. So by default, now I'm going to create a Spring Boot, a Spring Starter project. So this exercise, guys, you should have an idea on Spring Boot, guys. You should have a basic idea on Spring Boot, guys, here. Okay. So Amazon products or Amazon, what I can say here, Amazon use case, something like I'll take here. I am going to take a Maven project, com dot Amazon dot order, com dot Amazon dot order processing. So com dot Amazon dot order processing, where I am going to take Amazon use case, and I'm going to take this as I'm clicking on what are the things I need, guys, here. Spring Web. This is I'm going to take it. After that, Mongo, Spring Data MongoDB. Spring Data MongoDB. This is my MongoDB dependency. Sir, everyone I'm telling, guys, if you want to understand, you should have a basic idea of Spring Boot, guys, here. You should have a basic idea of Spring Boot. Then let me finish. It's going to take some time to create the project here. Meanwhile, I'll take, if I see any. Praveen, yes, I'm going to explain the question. Praveen, it's a good question. Okay, some questions came, guys. Now I'll take all those questions, guys, here. Yep. Yes, Tanmay. So his question was, We have a master table, payment table. Then we can create a separate document in MongoDB. You no need a document. Complete JSON is a document. Not only payment, complete JSON. All the JSON will be in the inside that. How to manage product management in MongoDB? Something like I'll create a JSON, right? In the JSON, I just now mentioned, right? All the things are a document here. This is entire things I'll make it a JSON so that I can manage this. Something like that. Okay? Right. Sorting pagination examples. By default, this is not a NoSQL. It's a NoSQL. Sorting, search, pagination, all those things we cannot use. Just to save the data and the database lookups, to minimize the database lookups, we can use it. How to set up MongoDB, I'm going to explain. It's not done yet. Now, while designing which database we should use, Praveen, I'm going to take some time. I'll explain that. It's a good question. I'm going to explain after a few minutes. That's what Sufyan and Praveen, both are same questions. I'm going to explain that. Okay? Yes, Akhilesh, correct. It is going to take automatically JSON data, BSON. That is what we call. Okay? Right. Kranti, Sufyan, Praveen, all those things, there is an advanced question which I need to explain over here. Yeah. Sorry, guys. Just give me some time here. So where it is going to take care of ordered JSON and new ordered JSON and order details. And this is the structure which we are going to manage here. Now, I'm going to explain. Okay. Right. So, Pram Prakash, I'm going to explain the situation after the some time. Now we'll go to the, we'll focus on these guys here, where typically this is my project is getting created, where I'm going to take it up in a new class, which is equal to dot model. I'm taking a model class, which I'm going to take a order object here, which I'm going to take a order object over here. Give me 1 second, guys. 1 second, please. Sorry guys, I'm sorry. I'm sorry. I'm speaking on mute, guys. I'm really sorry here. Yeah, yeah. I'm really sorry. Okay, right here. So where I'm typically taking order details, order ID, customer name, customer address, product, order total, payment details, payment done, shipment status. By default, this is my columns over here. And I'm typically taking at the rate of repository. And typically taking at the rate of repository, which is taking a Mongo repository, which is created by the Spring Boot itself, which is typically taken care by the Mongo repository, that is typically taken care by the framework itself, and it is taking internally order object as well as data type of the primary key here. And I'll take some derived queries. I'm going to write some derived queries. Which is list of order, find by payment done. How many orders are completed with their payment? How many orders are completed with the payment here? Boolean payment status. How many orders are payment? Right? I can make a query, guys, here. So what it is going to do that here? Select star from order where we have a column, right, guys, here. I told, right, is payment done, isn't it? Is equal to true. Only the columns which are done with the payment. That is a derived query. After that, I'll write one more query. Find by customer name. String customer name. How many orders are placed by which customer? Select star from order where customer name is equal to cust name. So what is the customer name, right? This is a column, right? Right. This is my customer name here. Right? So, sir, we cannot write lot of queries like this. We can only write one or two queries which are mainly important for us. That's it. I am not going to write a service here. I'll mix everything in a controller. I will mix everything in a controller. Ideally, I need to write a service, right? But we are not writing a real-time project, right? Something showcasing our data integration, right? Order controller, which I'm going to write over here. So, which is nothing but order controller over here, which is equal to at the rate of rest controller. After that, at the rate of request mapping, which is equal to slash API. Request mapping, which is equal to slash API, where I am going to do auto void at the rate of auto void private order repository, order repo, something like that. Okay. Now I'm going to get mapping, get all orders, get all orders, right? So public response entity of list of orders, right? List of orders. So which is equal to java dot util dot list of order, get all orders, which is equal to where at the rate of request param, I'm going to take a parameter which is equal to string cust name. Maybe is it optional? I don't think we may get all orders. I don't think we don't need here. Okay. Where return order report dot find all. So which is going to order repository dot find all, where dot for each I'm going to write order add something like I need to create array list because it's a list of order is equal to new array list of order. So which is equal to array list why it is giving error. So which is equal to okay. I need to write return new response entity. Okay. What I'll do is I'm going to find all order repository dot for all everything, and I'm going to do that. After that, return new response entity of orders, comma, HTTP status dot okay. Just like I blindly. I'm taking array list. I will add each and every order to that array list, and I'm simply return this here. That is my get a particular order here. It will give me all orders, guys, here. But if I want a specific order, get specific order public response entity of order get order by ID, where at the rate of path variable of ID, which is equal to string order ID. Okay. Optional of, because it's written optional, right, guys, here? Optional of order data is equal to order repo dot find by ID of order ID. So if order data dot is present, if order data is present, then return new response entity of order data dot get, comma, HTTP status dot okay. Right. Return new response entity of HTTP status dot not found. Something like that. I'm going to return here. So get a particular specific order, which is a specific order ID. If the order is exist, that order I will return. If the order is not exist, I'll return not found order. Something like that. I'm going to write a create order here. Post create order. So at the rate of post mapping, which is equal to slash orders public response entity of order create order at the rate of request body order ord object, right? Where I can write a try block order input object is equal to order repo dot save of new order, which is equal to ord object dot get customer name ord object dot get customer address get customer zip code. I think it's not there. Okay, that's fine. Get product, comma, ord object dot get payment details, ord object dot get shipment status. After that, ord object dot get already is not there, order total. So what is my order constructor? All are strings only. Only boolean is before that. False. Payment is not done right initially. By default, initially payment will not be done right, guys, here. So I'm going to set up a new order object with the details here, and I'm going to save this input object over here. So here, return new response entity of input object, comma, HTTP status code dot created. If any exception comes here, return which is equal to null. I'm going to give internal server error. I'm going to give internal server error. So that is related to post mapping. And finally, I want to give put mapping update, right? Put mapping, which is equal to slash order slash ID, a dynamic parameter, which is going to have a dynamic parameter, right, guys, here? So where public response entity of order, only one order will come, right? Update order, which is equal to at the rate of path variable of ID string order ID, comma, comma, at the rate of request body order ord object. So something like that. I'm taking a order and I want to take this order object here, right? If first of all, I need to get it right. Optional of order data is equal to order repo dot find by ID of order ID. If this order data is present, if order data dot is present, if it exists, now I need to update it. So order db order is equal to order data dot get. I'm getting the data. I'll update here. db order dot set customer address order data dot not here ord object, right? Get customer address. If customer changed any address, db order dot set customer name ord object dot set customer name, not set get. Set order ID, not order ID, set order total is equal to set payment details. db order dot set payment done ord object dot is payment done, right? db order dot set payment details is over, order total is over, set products is equal to ord object dot get products, db order dot set shipment status ord object dot get shipment status. So I'll set everything here. After that, return new response entity of what I'm going to do here, order repo dot save of db order, comma, http status dot okay. That I'm going to return over here. Else, I need to write else condition, right? Return new response entity of null, no, right, http status dot not found. Do you have not found? Yes, I have a not found case over here. Not T here. Response entity of response entity of order, right? New return new response entity YT here, not required. Yeah, that's it. Finally, I need to do semicolon over here, right here. This is over. Next one is what? Delete mapping, guys. I can delete a particular order right here. At the rate of delete mapping of slash order slash ID. Just I want to delete it here. Public response entity of HTTP status here. I want written status over here. Delete order of at the rate of path variable. Which order I want to delete? That order ID. So order repository dot delete by id is equal to order id string order id. Okay. After that, return new response entity of http status dot no content response entity. That's it. Finally, if I want to get only the payment details, the orders which are getting only which are paid at the rate of get mapping slash orders slash paid. That's it. Public response entity list of order find by paid paid orders. Return paid orders not return. Find paid orders. Right. So which is equal to list of order orders is equal to order repository, right? I wrote right this guys. Find by payment done. After that, Boolean payment status is equal to true, which our payment status is done. Then return new response entity of orders, comma, HTTP status. Status okay, or else no content. Return new, okay. New response entity. Right. So that's it, guys, here. So I almost did the code over here. Everything is done over here, guys. Okay. Right here. So this is the typical scenario. Now I want to go to this particular database over here, guys, where I need to write a database name here. Prior to that, I need to open. Someone will ask me MongoDB Compass. It's a simple installation, guys, here. Someone asked me how to set up MongoDB. Install MongoDB Compass. In that, yes, here you'll see here, install MongoDB using this executable file. So this is the, I'm giving here, this is, just you need to click next, 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 next. That's it. Apart from that, any other things here, which is by default MongoDB colon, this is my connection string, 27017 is the default port, guys, here. Okay. So Spring dot data dot MongoDB dot database is equal to something like I'll write Amazon DB. This is the database name. Spring dot data dot MongoDB dot database here. Next one is Spring dot data dot MongoDB dot port is equal to 27017. That's it. So this is the database name. This is the port number. That's it, guys. I almost completed the use case, guys, here. So what I have done here, I've created order table. Let me explain once again, guys. I created order table with the structure, order ID, customer name, customer address, product, order total, payment details, payment done, shipment status, right? And I've created order repository, find my customer. I mean, just like I've created how many orders which are done with the payment. I thought of using customer name, but fine, we'll see it later. And I've created all the orders here, get all orders here. So this is all orders, find all, every order I'm going to add it. And after that, get order by ID, a particular order ID, which is a path variable ID, string order ID. So find by ID, which is going to give me. After that, it is going to create an order. This is my order details. And whenever I want to update a particular order, I want to update. So I'll get the data first. I'll set all the data here. And finally, if I want to delete a particular order, I'm deleting this data. And if I want to find all the orders which are paid, so this is a paid order here. That's it, guys, here, right? Let me run the code. I'm running the code over here. Yep. You saw here, our Spring Boot application is started, 8080, and everything is started here. So let me open the Postman. Let me first create localhost 8080 API/orders. Is that correct? Endpoint is correct. Controller, right, sir? API/ first create order. API/order, a post mapping. Now, this is my data, guys, here. Customer name, I'll take Vijay. Customer ID Kukatpalli, and I'm looking for iPhone, iPhone cover protector. This is what I told, right? I have 1,25,000 and I have GPay, and payment is not done and shipment is not done, not started, something like that. I'm just simply placing an order, guys, here with this particular details here. Okay, just I'm simply placing an order with this particular details over here. So let me click yes. Now you see here a order is created, right, guys, here 201, which is created, and this entire order is created. Now we'll go to the schema over here. Let me connect here. You see here Amazon DB is getting created here, and I have an order document, right? I have order document. You saw Amazon DB dot order. It's the data is created, right, guys, here? Order document order, right? Now you saw a JSON data, guys, here. This is my typical JSON data, guys. One row. ID, this is a primary key. Customer name Vijay. iPhone cover protector, Google Pay, payment details not started, payment done false, shipment status this, and this is my data here. So a JSON data is getting created. Am I right? Now let me place one more order, guys, here. Let me take Madhapur, and she ordered O General AC adapter power switch, which is equal to 2,40,000. Payment is not done and everything is not done. So second record I am creating. Now you see two records, guys, here. Let me refresh over here. Is all right? Vijay order is created. Sandhya order is created. Vijay is ordered iPhone. Sandhya is ordered AC. Two orders. Payment details are not started. Payment is done. And shipment status is this. Now I want to make a payment, guys. Now I want to make a payment here. So let me make a payment for Vijay. So where I can have a put. This is my primary key. So this is my orders over here, guys. Here, maybe AK slash orders. Right here. Now I have a data over here. This one order. Vijay. My products. These are my products here. Order total. Google Pay. Payment details. Payment runs true. Shipment is started. Once the payment is done, shipment is started. Now I am making a payment of 1,25,000. My Google Pay and payment done is equal to true and shipment status is equal to status. Okay, just I am updating here. Right, it is updated over here, guys. Now you'll see in the data. Now payment is done, right, guys? Here it is updated, right? I see that payment is updated. You saw, guys? Payment is updated. Now I can get the data here, guys. Here I typically get a data over here. So API 8080 API slash orders. Now how to order slash paid. Now if you see here, orders is equal to slash paid. Payment return is equal to true. It should give me, right? Right. Maybe something that paid is not coming over here. That's fine. Maybe I want to update this particular data. Now I will update with shipment is completed. Once the shipment is also completed, let me update here. So it's updated, guys, here. So like this, my payment is completed, shipment is completed, everything is completed. So this complete JSON data, I was able to save in the Mongo database. Now, if I want to delete Sandhya record, so let me write delete. This is the record. Delete, what is that? Delete order slash ID. API slash order slash ID over here. API slash order slash method not allowed. Delete mapping API slash orders/id. API/order/id. I didn't write delete mapping. Order slash, not order. Right. Here you saw 204 no content. Data is getting deleted. So you saw that, guys. The data is deleted. So like this, we were able to perform end-to-end operations on the typical Mongo database here. Okay. So just I have a communication from my end, guys. Here I'm stopping my screen share for once. Okay. So I'm going to start a new batch tomorrow on a Spring Boot and microservices. There is a new batch on a Spring Boot and microservices. I'm sharing the details on the window. In the Zoom chat window, I'm sharing the details over here, guys. Okay. So the demo sessions are free. The demo sessions are typically free, guys, here. All the demo sessions are free. It's 7 p.m. to 8 p.m. IST. All my demo sessions are free. Please pass this message. Okay. Please pass this message to all the friends and everything. So which we need to continue here. So meanwhile, I'll take, if I have any questions, guys, okay, please things here. Right. Vamshi Krishna, soft deletion or deletion? Nothing, sir. Soft deletion is what? We'll update the record. We'll update the record saying that deleted will keep a record as a deleted, and deleted is equal to true. That is a soft deletion. Hard deletion means we are going to permanently remove the record. That is a permanent delete. That's a soft delete means update. Only will update a column. Deleted will take a column deleted, and if we say deleted is equal to true, then we are going to delete it. And while querying, select star from table where deleted is equal to false. That is it. Okay. Right here. Just like I show you Nidhi, I explained, right, how we can check that records are available, or I shown you, right? Yeah. If I have to update some table data without run put API like query update query, we use MySQL. Just like you need to write update query in the Mongo. We have a Mongo compass. We have a query statement. We can have a update it here. Okay. Right. Right. Now, how to decide? This is a question, guys. Very, very good. How to decide MongoDB and relational database, right? So, in a situation, if I have no major database call volume, 1 record, 2 records, 10 records, something, a small volume is there, I can go with relational. And also, we need to query the reports. How many products are sold? How many electronic products are sold? So if I have a data with more and data retrieval, then I need to use relational database only. And if I have more inserts, more updates, more deletes, less retrievals, then I can talk MongoDB. So one microservice relational database, another microservice MongoDB. Something like I told, right? This entire order details. I'll take relational database. Only products, order underscore products, right? I'll take MongoDB. This section I'll take MongoDB. Remaining section I'll take only relational database. So like that, I can decide, guys, here. Okay. Let me take any other questions here. Right. Yeah, we are going to share the project, guys, here. We're going to share the Git repository to your email. Whatever the email ID you logged in, we'll share this particular code here. Okay. Yes. Someone is asking what is the difference between MongoDB and Elasticsearch? It's a good question. MongoDB is a non-relational database. Elasticsearch is also NoSQL database, but that is managed by Elasticsearch ELK stack. MongoDB is managed by us, ELK. It is internally creating a NoSQL database. where we'll store all the logging related stuff or any non-documented format, we'll save it. Generally, ELK stack we'll use for distributed logging. Okay, right. Yeah, Tarun, it's a good question. If I want to remove a record, how to get the ID? So first of all, we need to query find by find all. When find all is querying, then I'll get an order ID or object ID, then I can use it. Or else you need to write a derived query. First get the data with name and get the IDs here. Yep. What is data collection notation? Collection is nothing but a document. A collection is nothing but a document. Like in relational database, we are going to use at the rate of entity, at the rate of model, right? In the similar way, we are going to use at the rate of collection. Okay. Yes. At the rate of query annotation in my MySQL MongoDB will not write, guys, here. I mean, it's generally for 99% of the cases, more and more data insertions, deletions and insertions, no retrieval, that time only we'll choose MongoDB. Yes. It is in real classes. I'm going to explain all these examples, right, guys? In real classes, this is a workshop. I gave a high level overview, but in real classes, we are going to see all those cases. Okay. Yep. In case of pagination, yes, we can use Sufyan, but I'll explain in my real classes because it's a workshop, right? I'm going to explain in my real classes here. Okay. Right here. Can we write a manual query like JPQL in Mongo? First of all, Bhavesh, Zope. Complex queries, if you want to use, don't use MongoDB. This is only for more of insertions, more of deletions with a high volume of data. That's it. Data retrieval, MongoDB, NoSQL. That is the point here. Okay. Yeah, someone is asking AppDynamics versus Elasticsearch. AppDynamics is typically about our CPU, about our health check, about our thread, and about our health of our application. Elasticsearch is something like some data you want to store in NoSQL, and I want to search something like logging. So that is a typical. Okay, right here. I hope I covered all the questions, guys, here. I didn't left any of the questions here. Okay. Yes. In real batch, I am going to take a mini project and I'm going to explain. Correct, Ashwin Kumar. Yes. Yes. Can we use SQL and NoSQL? Yeah, we can use simultaneously. Someone is asking to show the property file. Let me show the property file here. This is a property file, but we are going to share the code, guys. Nothing to worry. I'm going to share the code to your email ID with a YouTube link as well as Git link. I'm going to share it. Okay, right here. That's it, guys, for now. And I covered all the questions. I almost done with my agenda, but there are some things are available, relational versus non-MongoDB, but I'll explain my real classes, guys, here. Okay. Sir, we'll store it in the MySQL. How we will get from MongoDB, sir? It's invalid question, right? If you are storing the data in MySQL, how we can get it from MongoDB? It's invalid question. Okay, right. It's so only retrieval. Just I thought of showing, but in real cases you cannot use only retrieval. Primary key. That's fine, right? One retrieve I can do that, right? Okay, right. Thanks everyone, guys. Please communicate this message tomorrow 7 p.m. to 8 p.m. New Spring Boot batch demo sessions are free. Okay, and also 9 p.m. to 10 p.m. design patterns course by me. It's a free batch. Microservices design patterns is a typically free batch. Okay, so that also anyone can join here. Right here. Thanks everyone, guys. Have a great day. Thank you all. Have a happy weekend. Thank you.